Hello students, this is Shakil and today we are going to discuss the thermophysics topic from IGCSE Physics. Inside the thermophysics, we have to study about simple kinetic molecular model for matter. Well, about the syllabus content, we have to look for how many states of matter are there. We have to distinguish between the properties of the states of the matter like solid, liquid, and gas. We have to look upon molecular model, the molecular structure, movement, separation. Then we have to look for kinetic molecular theory, and then we have to look for the Brownian motion, which is the evidence for kinetic molecular theory. And we'll do some analysis about gas pressure, that how gas particles exert pressure. Okay, so now the first thing is about matter. You know that anything that have some mass and occupy some space or have some volume is known as matter. So basically everything around us is matter. Everything around us is actually matter. So atom is the basic building block of the matter. It means that everything is made up of atom. And there are three main states of matter. Well, solid, liquid, and gas. Okay, so about solid, you know that it has definite fixed shape and fixed volume. Its density is very high, you cannot compress it, and it's hard, stiff, and difficult to change the shape. While liquid, well, liquid is having fixed volume, but its shape is not fixed, and its shape depends upon the container. Its density is still high, and it is very slightly compressible. And the moving surfaces of the liquid, so it adopts the shape of the container. About the gas, they have neither fixed shape nor fixed volume. They have low density. That's why they can be compressed easily, and the atoms in the gas are far apart from each other, and they're free to move. And the shape again depends upon shape of the container. Okay, then we have to look for the molecular states structure of the matter in terms of the atoms, solid, liquid, and gas. As you can see, in solid, the atoms are jam-packed. They are very closely packed. And then atom only vibrate about their fixed position. They cannot leave their position. They just stay on their position and they just keep on vibrating. It means that if this is a solid atom, so it can just vibrate to and fro like this, like this. So it can just move to and fro. It cannot change its position permanently. And then atoms have very strong intermolecular forces or bonds between the solid. That's why they have definite shape and definite volume. In liquid, the atoms are found in the group known as clusters, like group of 3 or group of 2 or group of 4. So they found in group or clusters, and there are some spacing between these clusters, due to which they have slight chances of compressibility. So atoms can move past each other and can change their positions, and still they have strong intermolecular forces between them. About the gas, the particles, you can see they are far apart, far away from each other. The atoms can move freely and no or negligible intermolecular forces between the atoms as they are free to move anywhere. Well, about the gas molecules, movement and temperature, we have to see what's the relation between them. So we know that temperature is a measure of average kinetic energy of molecules in a substance. That's how we actually define temperature. Temperature is a measure of average kinetic energy of molecules in a substance. You know what is average? Average means like you have to find kinetic energy of all the molecules, and then you have to divide them with number of molecules. That's how you will get the average. So temperature of the substance is proportional to average kinetic energy or kinetic energy of one atom or molecule. So kinetic energy of matter or the gas particles depend upon temperature. Faster moving particles have greater kinetic energy, so they are at greater temperature. Well, now about the gas pressure. In the diagram here, this is a closed container having a piston on it, which is fixed. And then these small tiny particles are the gas particles. And you can see that these gas particles are randomly moving and they're colliding with the walls of this container. So how the gas exert pressure? So the pressure exerted by randomly moving gas particles while colliding with the walls of the container is known as gas pressure. So actually, when the particles moving randomly, they collide with the walls of the container, then they exert a pressure, and that pressure is named as gas pressure. So what's the reason? The reason is same as I've told you, it's a collision of gas particles with walls of the container. And as gas particles are free to move, like they can move anywhere, left, right, up, down. So during their movement, they have to collide with the walls. And as a result of this collision, their momentum changes, right? Their momentum changes. How their momentum changes, let me tell you. If one of the particle is of having mass m is going to hit the wall with initial speed u, then it is going to rebound with the speed v, right? So as you can see, the direction changes. So that's why its velocity changes and momentum also changes as well. So we say that whenever a gas particle collides with the walls of container, its momentum changes, right? So when its momentum changes, we can write it as change in momentum equal mv minus mu, where m is the gas particle mass, v is the velocity after the collision, and u is the velocity before the collision. Well, we know that force is change in momentum over time. So as momentum of the gas particle changes during its collision, so they have some contact time t with the walls when they're colliding. So we can say that the gas particle exert a force on the wall, and according to Newton's third law of motion, a reactional force acts on the particle as well. So the force per unit area of the contact is known as gas pressure. Like in the gas pressure, it's quite simple. We know that force is change in momentum over time. And then we know that pressure is force over area. And from here, change in momentum is mv minus mu. So first thing comes first. Well, this is the first thing, that when the gas particle are hitting the walls, their momentum changes. Then this is the second thing, when their momentum changes, then they exert a force as well, right? And then this is the third thing, that force over the contact area of the molecule is known as gas pressure. So that's how gas pressure is exerted. Okay, now we have to look for some factors which can affect the gas pressure. So the first factor is obviously it's the volume of the gas, and they are inversely proportional to each other. This means that if you increase the volume, then the pressure of the gas is going to decrease because they are inverse proportion. And the secondly, if you're going to decrease the volume, the gas pressure is going to increase. Okay. So the next factor is gas pressure proportional to temperature, directly proportional to T. So it's the same thing. If you increase temperature, pressure will increase. The third is gas pressure is proportional to amount of gas. If you fill more gas, if you increase number of particles, of course, the gas pressure is going to increase because then more collisions will be there. For all these three reasons, what's the reason for change in gas pressure? Well, it's common for all of them. Changes in number of molecules colliding with the container. If you, like in factor one, if you decrease the volume, then the molecules get closer to the wall and hence more will be colliding with the wall. So increase gas pressure. Number two, if you increase the temperature of the gas, the particles will have greater kinetic energy and greater speed, and hence they will collide more with the wall. So hence increasing temperature. Number three, if you fill more gas in the container, then of course, as more gas will be there, then more collisions will be there. Hence pressure will increase. Okay, now we have to look upon the famous kinetic molecular model of the matter. First, its statement. So matter, the statement says that matter consists of tiny particles which are set in random and continuous motion. So it means that matter, whether it is solid, liquid, or gas, it consists of very tiny particles which are known as atoms. And all of them are set in random continuous motion. Like random continuous motion. Random means that their direction, you cannot figure out their direction, and continuous mean that they are never stopping. So the part one of this is, like part one of this theory is that all matter type consist of particles or atoms. They are made up of atoms. And part two is all particles in or any type of matter are set into random and continuous motion. So as atoms are too small, so we cannot see them. So how we can tell that These are set in continuous random motion. So provide an evidence for kinetic molecular matter. Robert Brown put a theory which is known as Brownian movement. So Robert Brown was a physicist. He performed famous experiment to show the random and continuous motion of particles in matter. Hence, it became an evidence for the support of kinetic molecular theory of matter. So let's move on to it. Let's look here in the diagram. There are like two types of particles. The first particle is these one, the blue ones, the small ones, and the next ones are these red ones and the big ones, right? So now carefully look upon their movement as these are falling. So these are falling zigzag, zigzag, like they are falling zigzag. They are not moving along straight track. And the big particles are visible because of their size, and the small particles like the blue one, they are not visible because of their size. So when we see that these big particles are moving, so they seem to be moving randomly, zigzag on zigzag paths. Well, so that zigzag movement of bigger particles due to collision with randomly moving smaller particles is known as Brownian motion. So that's how we define Brownian motion. So this is basically the definition of Brownian motion. I hope this is clear to all of you. So this experiment proved that the kinetic molecular theory for matter is correct, and bigger particles, which can be dust or smoke, can be seen moving randomly. And why they can be seen moving randomly? Because of the collision of randomly moving smaller invisible air particles. So indirectly, they said that, as you can see that bigger particles are moving randomly. So this is because of the collision of smaller randomly moving particles. So which we have to prove that air consists of, or gases consist of, randomly moving and continuously moving particles. Well, you can see this Brownian motion and like at many places, like you can see in front of a lens of the projector when it is working, then you can see small dust particles moving randomly. You can see this when sharp ray of light enters in your room from the window. You can see that the dust particles moving randomly. You can see this in water. If you put some pollens or small grains in the water, in the static water, they will be falling down while moving along random path, zigzag path. So all type of these movements are Brownian movement. So we have to look for the pattern of Brownian movement by smoke particles enclosed in a jar. So let's say this is a jar and some smoke particles are there, along with, of course, air, as air is everywhere. So you can see that this zigzag red path is actually the track which is followed by a smoke particle, right? So smoke particle is moving along this path. It is moving along straight track, but it is changing its direction randomly. And this change in direction is completely randomly. There is no pattern for it. Why this direction changes? What's the reason for that? As the particles move along straight line until it collides with randomly moving air particles, and then they change their direction. So the Brownian motion, like every time the particle is changing its direction, it is bumping with a randomly moving air particle. So as the change in direction of smoke particle is random, so we say that air particles are randomly moving. Well, this Brownian motion is proportional to temperature. If you increase the temperature, like if you increase the temperature of this container by providing more heat, then the Brownian motion will increase. Well, what this means? It means that at higher temperature, smaller particles move faster, so they collide more frequently with bigger particles, and you can see the result over there, that the bigger particles will change their direction of motion more quickly. Well, that was all about today's lecture. We have to solve some past paper questions based on this. This topic is very simple. So what causes the random zigzag movement of smoke particles suspended in air? So what is the cause of the zigzag movement of the smoke particles? Air molecules colliding with smoke particles? Yeah, seems to be true. Convection currents as hot smoke rises? No. Smoke particles colliding with each other? No, because in Brownian motion, two different type of molecules should collide, like the bigger molecules should be colliding with smaller one. So smoke particles reaching with oxygen molecules in air? No. So its option is A, air particles colliding with smoke particles, because you can see air particles are the smaller particles and smoke particles are the bigger particles. Okay, now let's move on to the second one. A sealed bottle of constant volume contains air. The air in the bottle is heated by the sun, right? So let's say like there is a concealed bottle, and this bottle, let's say, is having air particles in it, like a lot of air particles are there. And you put that in sun, like the sunlight, okay? You can see that from sun, infrared rays or the heat radiations are coming. And of course, penetrating through the glass, and then the air become warm. And when the air become warm, the air particles will start moving more vigorously. So what would happen? What is the effect on average speed of air molecules in the bottle and the average distance between them? Well, you can see that when the air is going to absorb the heat, their speed is going to increase. So the average speed is going to increase. It cannot decrease. And average separation, the average distance between the air particles. Well, as they are inside the bottle and the volume is not changing like the constant volume, so of course it is going to stay the same, because the air cannot leave the bottle. Air has to stay over there in the bottle. That's why the average separation between the molecules will remain the same. If the bottle has to be expanded, or the air is leaving the bottle, then we can say that the volume, the separation is increasing. Okay. Next question. Very small pollen grains are suspended in beaker of water. A bright light shines from the side. Okay, this is a bright light and the microscope is there and the small pollens are there. Small bright dots of light are seen through microscope. The dots move in rapidly changing directions like this zigzag Brownian motion. What are the bright dots? So what are the bright dots? They are actually the pollens. The pollen grains being hit by other pollen grains? No. Pollen grains being hit by water molecules. Yeah, because in Brownian motion, the bigger particles are colliding with the smaller particles and they change their direction. And why they seems to be bright dot? Because they are reflecting light, right? Like if this is the pollen and light is coming, so light will reflect it. So when light will reflect it, and when it will reach the microscope and to the eye, it will appear to be a bright dot. That's why B is the option. Okay, well, a theory question, explain in terms of molecules why it is possible to compress a gas but not a liquid. So it's quite simple. In terms of molecules means you have to mention something about molecules, that why gases are highly compressible and liquids are not. So we can say that in gases, molecules have more intermolecular spaces as compared to that in liquid. That's why it's easy to compress a gas. That's enough. Okay, smoke particles are introduced into the glass containing air. Light shines onto the box so that when observed through a microscope, the smoke particles can be seen as bright points of the light. Describe the motion of the smoke particles and account for this motion in terms of the air molecules. Well, it's again the same thing. It's a Brownian motion, right? Like there is a jar and some smoke particles are there and some air particles are also there. So you have to explain, and some light shines on it. So you can see the movement of the smoke particles. So you have to describe their movement. And then you have to tell, by reference of that, you have to tell about the movement of air particles. So we'll say that smoke particles seems to be moving randomly along zigzag track. This is due to their collision with smaller air particles. This indicates that air particles are moving continuously and randomly. So that's a 4-mark description. And this is actually about Brownian motion. Well, next thing, figure shows the quantity of gas in the cylinder sealed by the piston, which is free to move. Okay, this piston is free to move. Some gas is there. The temperature of the gas is increased. State what happens, if anything, to the piston. Well, if the temperature increases, then of course speed increases. If the speed increases, the number of collision increases, and that increases the pressure. And when it increases the pressure, then piston moves outward. Piston moves outward, of course, as pressure is increasing on it. And what happened to the pressure of the gas? Okay, what happens to the pressure of gas? Of course, pressure of gas increases. Pressure increases because when you heat up the temperature of the gas, of course, its pressure increases. But later, when the piston is moving back, then it decreases again. Later, it decreases again. Because now when the piston is moving back, the volume is increasing, and you know, pressure and volume are inversely proportional. So firstly, pressure directly proportional to temperature. If you increase temperature, pressure increases. But later when the piston is moving back, then volume is increasing, so this will decrease the pressure again. Okay, the piston is now fixed at a place and the temperature of the gas is increased further. Okay, now they fix the piston and the temperature increases. So they fix the piston and temperature increases further. Explain in terms of the behavior of molecules what happens to the pressure of the gas. Well, the same thing, actually. So increase temperature will increase speed of particles. This will increase number of collisions with container. Hence, gas pressure increases. So that's a simple answer. Okay, next is MCQ. A gas is heated in a sealed container. Again, the container is sealed, the gas is there, and you are heating it up, right? The volume of the container does not change. Okay, it means that the volume is constant, it cannot change. What happens to the molecules? Well, it's quite simple. You know that the kinetic energy is proportional to temperature, or the speed is proportional to temperature. So the average distance between the molecules increases? No, because the volume is fixed. Volume is constant, so average separation cannot change. The average kinetic energy of molecule increases? Yes. The mass of each molecule increases? No, mass cannot change. The volume of each molecule increases? No, volume is also fixed. So it means that it's simple, the kinetic energy will change. Okay, thank you, students. Our next topic in the next video will be about gas pressure laws and calculations. See you over there. Thank you. Take care. Goodbye.